Hello! In this video, we're going to pick up where we left off in the last one, and we're going to start talking about creating interactions in A-Frame, having input that actually comes from the user to affect the scene. And as part of this, we're going to cover a couple different principles. We're going to talk about components, we're going to talk about raycasting, we're going to talk about lifecycle functions, we're also going to talk about event listeners, and how to change the attributes or the components, the properties of these entities. But first, we're going to cover something from the last video that maybe some people particularly astute might have noticed. But we're going to use this kind of an example case of how coding in WebXR and how web development in general can be a little challenging to pick up on when errors happen. Most notably, if you look at our scene, right, we never received any type of error messages or any issues based on our console here. But what you will notice is that the cylinder might not look like exactly what you would expect. Of course, if you've never seen a cylinder in A-frame before, you might have seen this is exactly what you were expecting. But what's actually happened here is that there was a minor typo in the height component for it, the height property for it. And just unfortunately, when you have typos like this, if there's some type of component like this doesn't actually exist, you don't get any type of feedback that it doesn't exist. There's nothing that says like, oh, something with the missing T doesn't actually, a height component doesn't actually exist. Do something about it. It just kind of silently fails again. So we can fix the typo and refresh it, and we'll see that we've actually raised the cylinder the proper height now. But that's just kind of an example of something to look out for. You really have to double check about having typos in your code. Sometimes it can lead to really obvious problems. Sometimes it can be very subtle and it might actually propagate elsewhere. So you really have to double check what you're writing and look over these things to make sure that you're validating all of your work. So with that said, let's talk about some new topics. So what we want to do now is actually add an interaction. We want to be able to do things in our scene besides just move around it, right? We want to be able to actually interact with the objects that we're seeing here. And the primary way of doing that in 3D engines and 3D interactions, the most simple is by doing a raycast. And so the concept of a raycast is basically drawing a line through 3D space from one point into the scene, into other objects, and seeing what it collides with and doing some type of interaction with that. And so you can do a raycast in any direction from any object in any way, right? You're just drawing a three-dimensional line and then figuring out some properties associated with what that line's doing. So you can have raycasts that come from, say, they come out of your cursor. Maybe you click on something, and what's actually happening is you're creating a ray that comes from the location that you're clicking on into the scene. So you're basically drawing a line through your screen into what you're clicking on, and whatever it touches first, you can do something with that information. And so to create that raycast, it's actually quite simple. All you have to do is go to the A scene. This is basically used for debugging in A-frame. But in your A scene, what you do is add a cursor component. And from this, you can specify the ray origin. And with this, we specify ray origin mouse. So you see we have like basically JavaScript object notation here. So you're actually passing in objects when you define these. So we're saying the ray origin is from the mouse itself. And we don't have any way of validating this yet because of course we haven't written any scripts for this. But now when we're clicking, we're actually doing a raycast into the scene now. So there's no way of really telling what's happening yet, but we'll get there. We'll get there within this video. But let's talk about potentially another way of doing raycasts while we're talking about this. And so what we're going to do now actually is talk about cameras a little bit. So A-frame gives you a default camera if you don't specify one, and that default camera is placed at a height of 2 from the ground so that you're not in the floor when you start, and is otherwise just a default camera. And if you're not familiar with what cameras are in 3D environments, when you're trying to actually render a 3D scene, you have to specify basically like what is actually looking into the scene, and that is called a camera. And so cameras can have a number of different properties you can change. You can change the field of view, so like how wide it is, how high it is in terms of what's actually being visualized. And with that comes, distortions, the type of projection that it's doing. This is an entire topic space that you can look into to see how virtual cameras can be defined. If you're really interested in that space, you can have different, like I said, different types of projections, different field of views. But the default camera suffices, and if you go into VR mode, you actually get a different type of camera specifically for VR headsets that accompany that view. So that's, again, something you'd really have to think about if you were creating this all from scratch, but A-Frame does a lot of the heavy lifting for you in that regard. So let's define our own camera now. And just for good practice in this case, what we're actually going to do is we're going to define an empty entity. We're going to give it an ID of rig. Essentially, we're creating a camera rig here, right? So imagine kind of in a physical analogy, you have your camera that can like turn and look around, and then you put that camera on like a dolly, like if you imagine like a film set, where that dolly can then move the camera around. So the camera itself is static on its reference object, but then the whole platform it's on moves around. And so this is especially important with VR headsets in virtual scenes because with the WebXR API, when you move around in the physical world with your headset on, it's changing the position of your headset. But if you were trying to programmatically change that position at the same time, it would cause a conflict of the position of the headset, and likewise for the rotation of it. So you don't want to do transformations to the camera itself, because it conflicts with what the WebXR API's data is trying to give you, and for the user, what it turns into is this extremely dizzy mess where their physical inputs are not matching what's happening in the world, and it can cause things like extreme nausea or disorientation or confusion in the environment. So instead, you want to have this kind of concept of putting your camera on inside of another entity and then manipulating that other entity instead. And so to actually specify any entity as a camera, all you have to do is add the camera component to that. And because we don't need to change any of the values on it, we're just going to keep the defaults. We won't associate anything else with it, but we will set the position to be, that same 2 height off the ground. And the other thing worth noting here is that by default, cameras have no type of input controls with them. And so to provide that, we're actually going to add 2 more components, one called look controls and one called WASD controls. And this will give us back the inputs that we had before with being able to actually move around the virtual scene using our keyboard, or likewise using a mouse to click and drag around. So we'll add those components on. It's a really important thing to remember. And we'll kind of give an example of what other connotations that has later on to show you how the SD component system can kind of work in interesting ways. But for the time being, the last thing we're going to add is we're actually going to put a child entity inside of the camera entity, and we're going to call it a cursor. So just like you saw the cursor component up here in the scene, we're going to make a cursor entity that's a child of our camera. And we'll just we'll give it an ID of cursor just in case you wanted to use that information. And we will also give it a Raycaster component in this case, so that this entity is now doing raycasts. And so by default, it will do a raycast anytime you have a click event, anytime it basically activates a ray. Or you can set it to be a timer. And if you wanted to do it based on a timer, what you can actually do is give it a fuse component as well. And there's multiple ways of doing this. So you can specify fuse equals true, and then you can likewise specify a fuse timeout. And so what these 2 pieces do is that instead of having it do a raycast every time you click, it could do a raycast after a set amount of time. Say you're using like a mobile phone as your headset, or something that doesn't have any type of controller input in a VR headset. You can have this input just automatically happen on a set interval. And this is in milliseconds, so we'll set this to 3000, which is equivalent to 3 seconds. So it'll do a raycast after 3 seconds of looking at a specific object. After hovering over a specific object, it'll do a raycast after 3 seconds. And so we've done all of this work, and we've added these other raycasters. And so if we go back to our scene and refresh it again, this time you'll see that we have this little cursor in here. You'll actually see that we're getting some warning messages now because when you have this Raycaster component, it's actually suboptimal to try to do raycasts against every object. In a scene like this, it's simple enough that it's not a massive issue. But if you read these error messages, you'll see that there's a specific syntax of defining which types of objects you actually want to have raycasts with, and that is a very important piece for increasing the performance of your application if you had a very object-intensive environment. But for the time being, we'll just kind of acknowledge that's a warning and we won't deal with that in this case. But you can look at the warning message there and account for that if you wanted to have a more complex scene with a lot of raycasting happening. So now we have our raycasts, so we have a way of the user actually interacting with the environment, but at the moment, nothing in our virtual environment responds to it. And so now what we're going to do is we're going to define our first custom component. And to do that, we're going to make a new file. So we'll go to the new file in glitch and we'll give it a name. This name we'll call it color toggle. Minor spoilers for what's coming up. That's fine. And we will add this file. So it'll create this new empty file for us. And now let's talk about the syntax of components in A-frame a little bit. So when you're creating a component in A-frame, the starting syntax is A-frame in all capital letters, and then this function call of register component. And what you pass into this is first you pass in a string for the name of the component, which we'll call color toggle. And this next thing we're passing in is actually going to be a JavaScript object. And so we'll have a comma here and we're going to hit enter on this because we're actually about to have quite the long variable being passed in basically. So we'll define this object. And what we're passing in now is a series of lifecycle functions that every component has. There's a number of them, and we'll talk about them kind of over the span of this tutorial, but we'll start off with the simple ones. The first being the init function. So we're actually creating a JavaScript object here that contains functions inside of it. And so we'll define this init function, and we'll just leave it empty for the time being. And the other function we're going to define is the remove function. And so what's happening in these lifecycle functions is that whenever a component is attached to an entity in the scene, it performs these lifecycle functions at specific times. So if a component, say, if we're looking at the components that are already here, right? Like you have like a look controls component. It has its own set of lifecycle functions that it performs. So if a component is attached to an entity at the start, when initially in the page, its init function will run right when the page loads. Otherwise, if a component gets attached to an entity after an application has already started, after an A-frame scene has already started running, the init function will run as soon as that component gets attached to that specific entity, and it's entity specific. So every component, every time it gets attached to an object, will run that. Likewise, the remove function will happen when a component gets removed from an entity, of course. So either if it's programmatically removed from an entity, but the entity still exists, or if, say, an entity gets deleted, the remove function will also run in that instance. And so these are kind of the most important lifecycle functions you'll normally see here. And what we're going to start off with for the time being is making sure that we actually include these scripts. This is something that's really easy to overlook. But every time you create a new script, you actually need to include it in your HTML file. So we'll have script source equals, and because it's a file in the actual directory here, we will just specify color toggle.js for the file name. And so now we have the script included. And so we have these lifecycle functions that are blank at the moment. And the next thing we're going to talk about is event listeners. So this is a standard web development function, but whenever something happens in a web application, an event occurs. So with those raycasts, what's actually happening is it's creating a number of events, but one of those is a click event. And so what we can do is create a listener on this component that listens for that click event if it's relevant to the entity that this component is on, and then it does something when it hears that click event. And so the specific syntax for that is the first thing we want to do is capture the reference to the entity that this component is on. And this will happen in the init function. So as we talked about with this let convention, so we'll say let el equal this dot el, because this component is given a reference to the entity that it is attached to. But this does not refer to the entity, it refers to this component itself, right? Because this component has its own data associated with it. And so we capture the reference to the entity, and EL is just kind of the standard convention for that, you'll see, but you could name it whatever you want. And the next thing we'll do is we'll specify a function associated with this component. So we'll do this dot color toggle equals function. And inside of this, for the time being, what we'll do is we'll just do a standard JavaScript operation, just alert. So this is kind of similar to console.log, except instead of being in the console, it appears on the screen itself. It's an alert that pops up in your window. You might see this when you get like spam messages on certain websites or things. It's generally bad convention to use it unless there's something really important to kind of basically block any of the other users' input until they deal with this alert that has popped up. But for the time being, we'll just use this as an example and we'll change this later on. And so the last thing we'll do in here is add the actual event listener. So you don't want to attach the event listener to the component. You want to attach it to the entity that this component is on, because that's where events will propagate through. So we'll do this.el, and then the actual function call is add event listen. And we specify the event we are listening for. In this case, we're just listening for the click event. And we specify the function that should occur when we actually hear this event. So we've defined our toggle color function, and we'll now pass that in. And this is where it's important to also have this in the remove function, because event listeners, if this component for some reason stopped existing, the event listener is still there. And that can cause bugs and problems if there is this kind of this pileup of event listeners that are never being dealt with even after the thing that they're relevant to is gone. It can either cause a whole host of error messages because it's trying to do these functions or this anonymous functions on components that no longer exist, or just for performance, you might end up having like thousands of event listeners on all these objects that no longer exist, and you're never dealing with it, in the form of like garbage cleanup. So we'll do this.el.remove event listener in the remove function, and you specifically want to specify the event that you're listening for, and likewise the function that you are removing it for. So you can have multiple event listeners listening for the same event and do different functions, so you need to specify both of these elements in both places. And so we've now specified our whole component for the time being, and we'll come back to our index.html where we've already imported the script, and now we'll see what it's like to actually attach this to one of our objects. So we've defined our whole component, and maybe we want to put it on like the cylinder. So we will put color toggle, because that's the name we specified in our script was color-toggle. It's just the same name as the file, but it doesn't have to be the same name as our JavaScript file. It could be anything you want. And now if we come to our scene again, and assuming everything worked, when we click on the cylinder, we get the alert to pop up. So we'll see that this is our first instance of having feedback. And you'll see that while the alert's up there, it's not taking other input on the screen. So this is why you don't normally want to have alerts pop up unless it's extremely important, because you're basically not letting the user do anything else in the environment. So you saw we clicked on the cylinder, but if we also hover over it, after 3 seconds, because of that fuse timeout, it still did that raycast into the cylinder and basically clicked on it. And so we see that our alert pops up again. So we have our first component we've defined, and we have some functionality and some feedback. But maybe living up to the actual name of the component, let's change this a bit to actually do something with this component. So instead of doing this alert, let's actually change the color. We'll toggle the color for it. And so to do that, we actually use the set attribute function. So we have a reference to our entity in the form of EL, and then we call set attribute on it, which is a standard JavaScript DOM function, document object model function, that you'd find in regular HTML. But in this case, we're modifying our entity inside of the A-frame scene. And we'll change the color of it, and we'll set the color to, let's say, red. So the syntax here is that the first thing you're changing is the property or the component. Even if you have components, you can customize the components and what the values are of that. And the second being what we're actually changing it to. So we're setting the color to red now. And if we come back to our example here and refresh it and then click on the cylinder, it changes to red. And just like that, we've created our first component. We can do things in the scene now. And because of the way that this entity component system works, we've defined this, this is completely generalized. So we have our color toggle component, and you could put it on anything. You could put it on the plane and just add a color toggle component to it. And when you come back to your scene and refresh, you starts with all its basic colors. But if you click on the plane, now it turns red, and the cylinder still turns red. So this is what's really powerful about defining components, is that it's this behavior, this generalized functionality that you can now associate with any of your objects in your scene. And we'll take it off the plane just so that our plane doesn't turn this nasty shade of red every single time. So this is the start to defining components. This is, we're just going to work on this from here. In the next step, we're going to see what it looks like to actually add in new objects on the fly. We've seen having components defined on everything at the start, but now we're going to look at what it's like to have things be even more dynamic. What happens if you want to have objects added into the scene after the application starts, or even components added into the scene after the application starts. So we'll get into some more advanced topics in the next video, but that is all for now.